Our next talker is Shahryar Khan from Ericsson. So Shahryar is expert and chief architect for multi-service transport network and architectures. Please go ahead.
Yep. All right, so basically I think this is our last presentation in our theme for this year, which is one network for a million different needs, where we are trying to connect the 5G, together with the rest of the ecosystem. So today the topic of my talk would be, for example, RAN transport integration and network slicing. This is, I'm afraid, maybe hopefully the last acronym that you learn today, RTI. So, and this is something that we are working towards a bit more, and then we'll see that how does this RTI tie together to the concept of network slicing, and how does it all fits in together with the 5G ecosystem. So just a quick recap of what we presented earlier in Dave's keynote, just connected together. So 5G, I'm quoting Dave again, 5G is not just a radio. It will have a trickle-down impact on, the overall ecosystem, which includes, for example, transport, packet core, RAN, so cloud, for example. So it will have an impact on all the, elements of the food chain. So 5G comes up with a variety of use cases and services, for example, like machine-type communication, which could be very critical, like, e-health applications. It could be like connected cars. It could be like, meters. And then these use cases come up with very, diversified kind of requirements. For example, it could be ultra high bandwidth, ultra low latency, ultra, high availability, ultra low availability. Is there something like that? No, just kidding. So it's just, you can have you can have on either side of the scale a lot of different requirements that you have to make sure how you can fit together in one network. So one thing that we are looking into is that maybe, how to break down the problem into smaller chunks, like, for example, have this notion of network slicing, which could help you to do that. And also this could be one way of offering, like, new business set of services. But I'll come back to it a little bit more later. So now let's look into the first concept of cross-domain integration. Here, what I would like to say is that in order to actually enable or to make sure that we can provide those kind of diversified SLAs in the networks today, is that we have to look into a notion of like orchestrated optimization. Today, if you look into, for example, the RAN transport cloud, or the NFV, for example, the packet core, each and every one is trying to optimize on their own. There is not really a global view when it comes to the optimization, and I think Mr. Lehman from DT was trying to say the same thing. So this is something that we are trying to also look into it, and what it will actually enable us is, for example, that it will help us to save, for example, some very expensive, spectrum, for example, when it comes to RAN, when it comes to transport, for example, if we can optimize it a bit based upon the information that we get, for example, from packet core or from the RAN, maybe we can utilize the resources in a much more optimal fashion. So then maybe we don't really need to throw bandwidth, indefinite amount of bandwidth, we can actually use it in a much more efficient fashion. So this is something that we are trying to look into it, how we can integrate tightly, for example, radio and transport, RAN and transport, for example, NFV and transport, for example, packet core and transport. So this is something that I'll delve a little bit more into the details. So the first thing that we started to look into a couple of years ago was RAN transport integration. We were initially looking for like some low-hanging fruits, but it turned out into something much more bigger. So there are two sides of the coin over here. The first thing is that, for example, if we make transport aware of the radio flows. For example, when I'm talking about the transport, if you think about it from the E node B to the packet core, the transport only sees GTB tunnels. We don't really see any subscriber flows. We don't really see any applications. So potentially all these flows, for example, from one base station towards one packet core could appear as one IP flow in the worst case scenario. So what it means is that if we can get more information about the subscriber flows, I'm not saying that we should get it per subscriber information, for example. We might be able to aggregate these flows in a much more intelligent fashion. For example, it could be like a group of subscribers. It could be like, for a particular network slice, enterprise users, for example. Then maybe we can offer some differentiated service offerings, for example, like have, different traffic engineering paths, based upon different SLA requirements. And then the other side is actually even more interesting where, for example, you make radio aware of the transport. So this is where, for example, if we can give information about, for example, the real-time utilization of the transport to the RAN, and based upon that, RAN can actually look into it and see that, okay, maybe I can offload some of my subscribers to another base station which has a better transport characteristics. So what it will give you is better overall optimization. So these are the use cases that I'll describe a little bit more. So let's look into what is this RAN transport integration. So what we have done is that we are looking into like having these entities, which we call it as like RTI. You can see that there is a central RTI entity, for example, for the transport. There is one RTI entity, for example, or multiple distributed RTI entities for the RAN, and then you can have, for example, for the packet core domain as well, distributed RTI entities as well. From the transport perspective, for example, what we are doing is we are trying to actually know a little bit more, as I said, about the RAN flows. We try to superimpose these flows on the transport topology, and we know about the service endpoints. So for example, if something happens in the transport, we are able to correlate it through the analysis module that you can see over here, and then we can take some policy decisions as well, which result in some actions either in the transport domain itself for optimization or towards the other domains. So this is something I'll explain in this use case. So this is the use case where we give more information towards the RAN, for example. So let's see what happens. The first step is, for example, in the lower, So what happens is, for example, in the lower half of the network, we see some congestion conditions, for example. Straight away, we get this information, we do some policy, based upon these analytics insights, we are able to do some analysis, correlate this information. We are able to tell which E-node Bs, for example, are getting impacted because of this link, for example, if it's getting congested. We give this information to the RAN, and RAN then has an extra parameter about the transport condition, and then they can maybe offload some of the subscribers to actually alleviate this congestion condition. What's the result? We get overall improved quality of experience. So this is one use case, and we have this in the demo in our booth as well. The second use case is the other side of the coin, as I was saying, that if we can get more information about the subscriber flows, we can actually straight away, if RAN and packet core can add more entropy in terms of, for example, the flows that we see, then we can automatically load balance the traffic. We don't really need to do anything specific in the transport. It happens automatically. But if you need, for example, specific TE paths, for example, based upon certain SLA characteristics, that is also something that we can do based upon this information. For example, for certain, for this extremely low latency application, for example, we can choose certain path as compared to, for example, a normal mobile broadband traffic, which can just go over, for example, the default path. Let's now look into the notion of the network slicing and see that how cross-domain integration can help us to achieve, for example, network slicing in simple ways. So if you look into network slicing, my idea over here was just to give you an idea about the definition of a network slice. Network slice is basically an end-to-end logical network. It's not just a slice of the transport, it's not a slice of the packet core, not from the RAN, it's an end-to-end logical network. So what we do is, and it's composed of the resources from the RAN, transport, cloud, network management, and put together in the form of an end-to-end logical network. And this logical network should serve a business purpose. For example, you can have this logical network, for example, for enterprise, for critical machine type communication, for your normal mobile broadband that you can offer as a wholesale, for example, to your customers, for example, like B2B kind of a model. So let's look into it very quickly, some of the considerations for the network slicing on the transport. I discussed this cross-domain orchestration aspects. So here, it's not just the cross-domain orchestration. I think it's also the question is how much information you have to expose between the domains. What is the frequency of the events? So how does it scale? So all this is something that we are looking into right now, and this is something that we are demonstrating in our booth as well. And then I think at the end, it's also, at the end of the day, you also have to make sure that the slicing needs to scale in and scale out. If you are scaling in and scaling out one slice resources, it should not adversely impact the other resources of the other slice, for example. So this is something that we also have to cater for. Very quickly, something to do with, we in any case will have, for example, central cross-domain orchestration function, which will exist in any case, which ties together, for example, stitches together the slice resources from different domains and stitch them together in the form of slice. But I would like to highlight this direct cross-domain integration. So we see that this could be useful, for example, my apologies for the font.
Sorry, as per your request, 10 minutes in.
Sure, thank you. So basically, what this can happen is that you are also able to exchange information, for example, like this flow mapping and the policies for the flows. That could be exchanged, for example, directly between the domains. It could happen in runtime as well. For example, packet core might decide to change the policy, for example, for certain users, and that might be communicated to us in real time. So this can happen, and also what can happen is, for example, we can also provide this abstracted view of the topology to both RAN and packet core. And based upon that, they can decide, for example, where to place the network functions in a, maybe in a more efficient manner. So this is something that we are also looking into it. Network slicing, we have looked into it from the whole life cycle management perspective. So you have a planning and instantiation phase. You have a runtime phase. And then, for example, you will tear down, the slice, or what we call as like, you can retire the slice or take away some of the resources if they are not in use. So in this case, if you look into it, what we have looked into it, I'll just go through a couple of use cases. Starting off with the basic instantiation of a slice. I'm not going to talk about the end-to-end orchestration in detail, but I'm going to talk about more so from the transfer perspective, just to give you guys an idea about it, what it all means. And then I'll look into a couple of use cases when it comes to, for example, how does this scale in and scale out, for example, works. In one use case, I'll show you that the domains will try to optimize, independently of each other. And in the other use case, we'll see some cross-domain interaction as well, where we will try to see the benefits of this in runtime case as well. So this is something I'll try to show. So let's look into it from the instantiation perspective. So we have basically two data centers, for example. This NGCO, for example, means next generation central office. Consider this as a data center. And you have, for example, two data centers. You have this central RTI entity, which is sitting close to the control, orchestration, and management domain for the transport. We have the packet core, we have the RAN, and we have the RTI entities communicating with each other. So initially what we are trying to do is we are trying to exchange, for example, even before the instantiation, as I said, transport can tell the packet core or the RAN, for that matter, about the topology characteristics, because it's a real network, it will be a live network. There will be other slices in the network in any case. So you're building, you don't have a greenfield kind of scenario. So in this case, the assumption is, so it will be worthwhile to give this real-time topology information, for example, to the packet core. Based upon that, for example, they can make a decision where to place even initially the packet core resources, depending upon, for example, the latency requirements or the bandwidth requirements. And then on the other side, we can also get this flow mapping or the constraints, etc., from the packet core or the RAN. Now, for example, let's go through very quickly the instantiation aspects. For example, the cloud resources could be instantiated first. Together with that, for example, the packet core subnetwork instances will be created. Right now, if you look into it, we will have two slices, dark green and you can say that white. So the dark green slices is, right now you'll see that all the resources are being instantiated in the upper half of the network, and for the light green ones, it's on the bottom half of the network, for example, over here. Similarly, RAN resources will be allocated. We have a green bubble coming up on the RAN side as well. And then now the thing is, once you have these endpoints set up, either it could be through the NFV orchestrator or through the central orchestrator through which you can actually request the transport to configure the policies which were exchanged earlier, or establish a transport path based upon the policies which were exchanged earlier. Or, it can be, we can also discover, we are also looking into if we can actually discover this instantiation in real time. For example, you can have a use case where you have 10,000 thousands of eNode Bs, and then you don't want to have slice configurations from the transport perspective being pushed on all those eNode Bs, right from the start. So we are also looking into it, how we can discover this instantiation as well. In any case, to keep it simple, somehow we have this information, the trigger comes, and the transport path is set up as well. For example, the top green slice provides you some bandwidth guarantees and some low latency, and the bottom slice is looking into some best effort services. And then this end-to-end slice is created. Now let's look into the scale out, for example. If you look into it, what has changed is over here is, in the previous slide, we didn't really have any users for the dark green slice in the bottom half of the network. Now let's suppose some of the users have roamed into the bottom half of the network. Maybe there's a sports event or whatever it is. So maybe we might have a default path to actually transport this to whatever was the EPC chosen. For example, it was chosen to be the top one as well. Now there could be, for example, a certain surge of traffic. Maybe, as I said, there could be a surge of users coming in over there. This surge will be detected both by the transport, for example, in terms of increased bandwidth, and by the packet core in terms of the subscribers which are trying to connect. So the policy check, for example, on the packet core, we'll look into it. Do I need to scale out? The answer in this case could be yes. So it's going to scale out, for example, on the same site. Similarly, we will also do some analysis. If the policy was that yes, to actually, we will have the policy that to, for example, increase the bandwidth to a certain extent, and then we'll provision that path. Remember, initially there was just a default path. So now we'll provision the path as per the policy for that green slice over there as well. So now we have even the transport coming in from this bottom half of the network. New additional bandwidth will be provisioned. And then we will also try to do an impact analysis against the bandwidth for example, so that it's not going to impact the other slices. And then we provide this update to the packet core.
2-minute warning.
Sure. My last slide for the use case is over here. In the second use case, what I'm going to do is, I'm going to scale out now. Let's look into it, what happens. So here we can see, for example, even more bandwidth, comes in, SLA is violated, for example. Now the policy could be, if this happens, for example, if it goes beyond a certain threshold, we can actually send this information or provide this information to the packet core, for example. Maybe we can't do anything in the transport domain. So now what packet core, we say, Mr. Packet Core, you're from this access point to this data center where you have this packet core, we are having some congestion conditions, or we are not able to handle it. Can you do something about it? So because they have the topology view, they know that, okay, for example, there is another data center which has better transport characteristics over here, so they will provision the additional virtual EPC, for example, over there. This will then they will tell us, okay guys, we have configured a virtual EPC over here, can you provision a transfer path to it now? So this is something then we'll actually, add more bandwidth, for example, over there, and the new LSP will be created, and then we'll send them the topology update. So this is how we can actually, you can see that transport was able to optimize based upon the action taken by the packet core. So this is something, and the same thing would have happened that you saw the use case earlier. We could have also given this information to the RAN, and the RAN could have maybe offloaded to a different access site or different RBS, to choose maybe to the same packet core instance as well. So this is all something that we are looking into it, how you can actually optimize it in unison, how in together in a much more coherent manner. My last slide. So we see that there's the road from 4G to 5G, for example, where you will see a sudden surge of bandwidth, very low latency requirements. The question is, so this journey to the 5G from 4G will be helped through the network function virtualization, which gives you the flexibility to actually move your virtual network functions, around in a much more flexible and distributed fashion. And similarly, the programmability, abstraction, and also the analytics capability, for example, in the transport, can help you to achieve, provide the SLA assurances for this kind of network. And then I've introduced the notion of this cross-domain integration, where you are talking, where the different domains, RAN, transport, or packet core, can come together, and then we can make like more global decisions based upon more global picture rather than individual domains to achieve the superior performance. Yep, thank you. So and if you need more information about, we have in the demo, so we can discuss it further over there. Thank you.
Okay, fantastic. Thank you very much, Shahryar. Before you are released from duty, are there any questions from the floor? One question from the gentleman at the front, please. If you could, sir, please introduce yourself.
Hi, thanks for the introduction. Vladimir, mobile operator. Could you give some thoughts about fog networks? Is it this integration is a main part of fog networks, or it's just simple needs for fog networks, or it's some other things and which don't have any things which is component for fog networks?
I think when we started off to look into this, obviously fog networks or fog networking was not in the perspective. But obviously, I think this is something that we are looking into it from the niche, from the 5G perspective, what applications it can, or what requirements it can bring on the table, and what could be the impact on the transport. So this is where we were coming from. Of course, we can look into it, how it could be integrated, for example, with the fog networking as well, yeah.
Any further questions, please? Okay, thank you once again, Shahryar.
Yeah, thank you.